Hi guys, this is Further Pure Maths, Edexcel 2019 Paper 1, Question 1. So let's get straight into it. Factorize this. Guys, it's 1 mark. Hopefully, if you're doing further maths, guys, you can factorize this. I'll just do it quickly. It is x minus 2 times x plus 1. Okay, then he says, hence or otherwise, show that this is a factor of f of x. Okay, now, this is, guys, actually the factor and remainder theorem. If this is a factor, then these two must also be factors. So I'm just going to say if x squared minus x minus 2 is a factor. Now, it's a show that question, guys, so you should really explain what you're doing. So if this is a factor, then x minus 2 and x plus 1 are factors. Then, if they are factors, f of 2 should be 0 and f of negative 1 should be 0 using the factor theorem. So let's get f of 2. F of 2 is equal to, I'm subbing it in here, it's 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6. This is equal to, you can use your calculator, guys, it's 8 plus 8, which is 16, minus 10, minus 6, which is 0. So that is 0. And I should also get f of negative 1. So f of negative 1 is negative 1 cubed, negative 1 cubed, plus 2 times negative 1 squared minus 5 times negative 1 minus 6. This equals, that's negative 1. This is plus 2, so now that's 1. Plus 5 is 6. 6 minus 6 is 0. Therefore, they are both factors. So I'll just write as f of 2 equals f of minus 1 equals 0. They are factors. And remember, we said if this is a factor, then these are factors. So if these are factors, this is a factor. Okay, that is question 1 done. Question 2. Given that this can be written in this form and c is prime, find the value of a and the value, find the value of a, the value of b, and the value of c. Show you're working clearly. Okay, so we have, guys, this is obviously something you can do on your calculator. Although, well, note, first they say show you're working clearly, and secondly, they often kind of force you to put it in a way, in a form that your calculator doesn't actually give you. So let's do it without the calculator. The trick is we need to multiply above and below by the conjugate of the denominator that will remove roots from the bottom, which is rationalizing the denominator. So we're going to multiply by 5 plus 2 root 3 over 5 plus 2 root 3. This is the conjugate of this, which is just this with the opposite sign. And we multiply the top and the bottom so as not to change the value. Okay, so if we put this in a bracket, and then this is in a bracket, this is in a bracket. Okay, 4 times 5 is 20. 4 times 2 root 3 is 8 root 3. 2 root 3 times 5 is 10 root 3. And then 2 root 3 times 2 root 3, guys, just, you can use your calculator if you need to, but that's actually going to be 4 times 3. 2 times 2 is 4. Root 3 times root 3 is 3. 4 times 3 is 12. So that's 12. And then the bottom is going to be 5 times 5 is 25. Then we have plus 10 root 3 minus 10 root 3. I'll just write that. Plus 10 root 3 minus 10 root 3. They will cancel, which is the point of this whole thing. And then this is minus 12 for the same reason. Okay, this then becomes, the top is 20 plus 12, which is 32. And then it's plus 18 root 3. 32 plus 18 root 3 over, these cancel. 25 minus 12 is 13. C is prime, so that's it. I'm pretty sure, guys, your calculator would give you that, so you can obviously check your answer with the calculator. Okay, that is question 2. Question 3. in a triangle ABC. AC is 7, BC is 10, and angle BAC is 65 degrees. Find the nearest degree, the size of angle ABC. Okay, let's draw this, guys. ABC, AC is 7, so BAC is 65, guys. So let's just do it like this. Let's do BAC. So let's say C is here. Okay, let's do this. This is 65 degrees. So let's say this is C and this is B. So BAC is 65 degrees. Yes, I will join this, guys. And find to the nearest 0.1 degrees this angle, the size of the angle ABC. So he wants this guy here. Let's call this theta. This side AC is 7 and BC is 10. Okay, so this guy's part A at least is straightforward. This is just a sine rule. So I'm going to do sine theta over 7. This over, sorry, sine of this over this angle equals sine of this over 10. So sine 65 over 10. Multiply across, sine theta equals 7 sine 65 over 10. And then theta is the inverse sine of this. So let's just get this out here, guys. Let me put it over here. So we have, let me just go home. Go up here. Okay, so theta is the inverse sine. Now note, guys, I am in radians. I need to be in degrees. Okay, go home again. Okay, now I'm in degrees. I want the inverse sine, so shift the sine, inverse sine. I want a fraction. I want 7 times sine of 65 over 10. Close this. 39.37. 39.37. He wants to the nearest 0.1 degree, guys. This is 39.4 degrees. Okay, then he says find in centimeters squared to 3 centimeters the area of the triangle. Okay, if that's 39.4, this angle here, guys, has to be 180 minus 65 minus 39.4. So let's actually do that first. So this is going to be 180 minus 65 minus 39.4, which gives me that. Let me just change that to decimal. So it's 75.6. So this angle here is 75.6. Now I need that angle because the area of the triangle formula involves two sides and the angle between them, hence why I'm doing that one. So, and it is then a half AB sine C, so it's a half 7 times 10 times sine of 75.6, like this. Okay, that I will do on the calculator, guys. This is a half 0.5 times 7 times 10 times sine 75.6, close brackets, 33.9. So the area is 33.9 centimeters squared. Okay, so far so good. That is question 3. Next question, question 4. Okay, I think, guys, I'm gonna have to zoom out a bit. Okay, so figure 1 shows a sector. Okay, fine. The circle has center O. Find the point C divides OA. So point C divides OA in the ratio 2 to 1. So 2 to 1, fine. And the point D divides OB in the ratio 2 to 1. Okay, fine. Although I could now, guys, put in here that this is length 10 and this is 5. This is 10 and this is 5 because 2 to 1 and the total is 15. If you want to do 15 divided by 3 times 2 times 1. Anyway, that's a ratio of 2 to 1 for 15. Okay. The area of the region, shaded, this region is 100. Find the value of theta. Okay, so this area, guys, is the area of this sector minus the area of this sector. Okay, I'm going to do it up here, guys, just so we can see everything. So area of the big sector, area, let's just call it big. Area of the big sector is, we're in radians now, guys. So the area formula for a sector is a half or squared theta. Okay, so the area of the big one is a half 15 squared times theta. That's 15 squared is 225, so it's 225 over 2 times theta. The area of the small one is a half 10 squared times theta, which is 100 times theta. 100 over 2 is 50, so that's 50 theta. Now we know that the shaded area is this minus this, so 225 over 2, let's just do that, guys, here. So 225 over 2 theta minus 50 theta equals, that I'll do with the calculator, guys, so I don't mess up. Okay, 225 over 2. That says 225 over 2 minus 50, essentially, which is 125 over 2. Okay, let's just write this as a decimal. This is 62.5 theta. 62.5 theta. Now he says this equals 100. The area is 100. So 62.5 theta equals 100. Theta is therefore 100 divided by 62.5, which is, I think that's a nice enough number, guys. 100 divided by 62.5 is 8 over 5. 8 over 5, or 1.6. Fine. Then he says, so this equals 1.6. Then he says, find the perimeter of the region ABDC. This ABDC. Okay, so let me see, guys, how are we doing for space? I'm just going to copy this down here. I'll put it here because I'm out of space. Okay, so the perimeter will be, okay, the perimeter is going to be 5 plus 5. Perimeter equals 5 plus 5 plus this length plus this length. Let's just call this length x, and I'll call this length y. So it's 5 plus 5 plus x plus y. Now, the arc length x is equal to get the arc length, we just do 10 times theta, or radius times theta. So it's just 1.6 times 10, which is 16. And to get y, we just do 1.6 times radius, which is 15. 1.6 times 15. That, guys, I will use the calculator for. 1.6 times 15 is 24. Okay, nice number. Therefore, the perimeter equals this plus this is 40, plus 5 is 50. So the perimeter is equal to 50. Okay, that's question 4. question 5. Given that, let me zoom in, guys. Given that f of x can be written in this form, find the value of a, b, and c. Okay, so essentially complete the square. Okay, so what we'll do is, let's say f of x equals, so I'm going to take out the 3, guys, from here, and then I do 3. I'd like to do a big bracket here, actually, so x squared minus 3x. So I've just taken it out of these first two. The plus 5 is at the end, doing nothing. Leave it alone until the end. Okay, then this becomes 3 times big square bracket. I complete the square here, which means I half this -3, and I bring in a new bracket. So it's x minus half this, 3/2, close bracket, square it. Then I always subtract this squared, whatever it is. In this case, it's 3/2, so it's minus 3/2 squared. Let's just skip a step and write 9/4, and then I'll do plus 5. This then becomes, sorry guys, I forgot to close that bracket importantly. Okay, this then becomes, multiply out this bracket, 3 times x minus 3/2 squared, and then minus, I have to do 3 times this, so minus 27/4 plus 5, and then finally 3 times x minus 3/2 squared. This is minus 27/4 plus 20/4. You can use your calculator here, obviously, guys, but that will be minus 7/4. So find the values of a, b, and c. Well, a, let's just do it over here, guys. He does want you to say what each of them are. A is equal to 3. B is equal to, be careful, 3/2, because it's in the form minus b. And then C is equal to negative 7/4, because it's plus c. Okay, then he says, write down the minimum value of f of x. The minimum value, guys, is this c value. So let me just do part B. I'll just do it here, guys, but you know you are not to do it here. You're supposed to do it below. So bi, the minimum value is the negative 7/4. And then the value of x at which this occurs is the, well, it's actually the b value is 3/2, but it's whatever this is here and the opposite sign. So in this case, it's just 3/2. Okay, that is question 5. Question 6. I think we need to zoom out. Okay. Figure 2 shows a lawn. Okay, fine. A, B, D is a rectangle of length y. Okay, fine. And with 2x, each end of the lawn is a semicircle of radius x. The lawn has perimeter 90 and area s. Show that s can be written in this form. Okay, so s is the area. Okay, so it's certainly, again, guys, I'm going to write up here, but you don't. So s is equal to the area of the rectangle. So let's do this. This plus, it's actually the full circle, guys, because it's like 2 semicircles. So the rectangle is xy. Rectangle is, no, sorry, it's 2xy. So it's 2xy. And the circle is 2xy plus, the circle is pi r squared, and the radius is x, so it's pi x squared. Okay, so that's s. But he wants it in this form, and this form doesn't have a y in it, so we need to get y, and the way we will get it is using this 90 perimeter. Okay, so down here, the perimeter P is equal to y plus y, so the 2y, plus, it's actually the circumference of a circle, because we've got half the length of half a circle, and then another half of a circle, so it's a full circle. So it's perimeter is equal to 2 of these y's, this one, plus the perimeter of a circle, which is 2 pi r, and again, it's 2 pi x. Okay, but he tells us this is equal to 90. Okay, now in order to get s in this form, we need to remove y. So I need to find or make y the subject of this formula here. By the way, I can divide by 2 here. So 2, 2, and 45. And then I'll subtract this. So y is equal to 45 minus pi x. Therefore, s is equal to 2xy, so 2 of these, 2x times this, 2xy, that's my y, 2xy plus pi x squared, pi x squared. Okay, let me move down. I have to turn this into this. Hopefully it will be that. This is 90, 90x plus, no, sorry, minus 2 pi x squared plus pi x squared, which is equal to 90x minus pi x squared, which is what he wanted, which means k, therefore k equals 90, because it's like, well, it's obviously 90x, kx. Okay, then he says, use calculus to find two four significant figures, the value of x for which s is a maximum. Justify that this value of x is a maximum value of s. Okay, so when he says justify, guys, this means the second derivative. We're going to have to get the second derivative, and the second derivative should be negative if that's a maximum. Okay, so this is s here. Okay, we're doing now part B. So if this is s, we are going to get ds dx, the derivative of s with respect to x. So this becomes 90, because it's just 90x, and this will become minus 2 pi x. Okay, now where is this where is this a maximum? Where it's where the derivative is equal to 0. So I'm going to say at max ds dx equals 0. So 90 minus 2 pi x equals, this equals 0. 2 pi x equals 90. X equals 90 over 2 pi, or 45 over pi. Okay, now he wants, sorry guys, what's he asking for? He says use calculus to find two four significant figures, the value of x for which this is at a maximum. So this, he wants it as 4 significant figures, so we have to, I guess, give him what he wants. We should do 45 divided by pi, which is here. 45 divided by pi, 14.32. So this is 14.32. Now to justify that it's a maximum, I have to get the second derivative, d2s dx squared. So this is the first derivative. The second derivative I get from this, the 90 turns to 0, and this just becomes negative 2 pi. Now remember I said if it's a maximum, the second derivative will be negative. So I'm just going to write as negative 2 pi is less than 0, stationary point, or let's just say it is a max. You could also justify it, guys, by the fact that this is a negative quadratic, hence it's going to look like this, and it's obviously a maximum, but that's the more common way to do it, and certainly if it wasn't quadratic, you would need to do that. Okay, then he says find to the nearest whole number the maximum value of s. Okay, now remember guys, s is 90x minus pi x squared. So s is 90x minus pi x squared, and we know the maximum occurs at 14.32. So we just have to sub that in here. So 90 times 14.32 minus pi times 14.32 squared equals, okay, 90 times 14.32 minus 14.32 squared times pi 644.57. 644.57. He says to the nearest integer, I believe, to the nearest whole number. So 645, therefore 645. Okay, that is obviously, guys, a long question, but if you know the process, hopefully not too bad. Okay, that is question 6. They gave us a lot of space to do that. By the way, it's 11 marks for that question. Okay, question 7. Solve in degrees. Do 1 decimal place this. And they're only giving us 2 marks, guys. That seems quite harsh, but fine. So, 3 cos of theta plus 5 times 5 sine of theta minus 3 is equal to 0. So we have to do either, we'll just do either 3 cos theta plus 5 equals 0, or 5 sine theta minus 3 equals 0. Cos theta equals negative 5 over 3, or sine theta equals positive 3 over 5. The solutions for this one are cos of theta is negative 5 over 3. So I'm going to do inverse cos of, now guys, I like to just do negative 5 or just positive 5 over 3. No, sorry, I just realized this has no solution. I was wondering why it has only 2 marks. So this guy, because cos cos has to be between negative 1 and 1. So this is less than negative 1. So we can just say no solution. And then this one, theta is therefore equal to, if we do inverse sine, we're in degrees, guys. Let me get rid of this. So inverse sine of 3 over 5 is 36 point, does he want to do 1 decimal place? Fine. 36.9. 36.9. But it's between 0 and 180. So remember, there's another solution at, if we draw our unit circle diagram, guys, there is an angle here. That's your 36.9. But there's also one here. So this is 180 minus 36.9. So here I'm going to write, or theta equals 180 minus 36.9. 180 minus 36.9. And I get this, which is 143.1. So 143.1. Okay, that's part A. Then part B, show that the equation, this can also be written in this form. Okay, 5 marks, guys. This is not going to be simple, I'm guessing. Okay, so we have 8 sine x minus alpha, right? So if we use our compound angle identity, guys, this guy becomes, it becomes 8 times, I'll put a bracket here. So sine A minus B is sine A. So it is sine, just make sure you can do this with your, from the formula book, guys, but it's sine x cos alpha minus sine alpha cos x. And then this guy becomes, this equals 3 sine x plus cos alpha. Okay, now I realize I'm low on space, so what I'm going to do is this is going to go here. I'm going to go outside the box. No, I'm not. I'm going to do this. Okay, this is then 3 times sine x cos alpha plus sine alpha cos x. Okay, now he wants tan x and tan alpha, so I'm thinking let's okay, so here we have a sine x cos alpha, and here we have a sine x. Okay, let's I'll tell you what we'll do. Let's multiply this out. So this is going to be 8 sine x cos alpha minus 8 sine alpha cos x equals 3 sine x cos alpha plus 3 sine alpha cos x. Don't do that, guys. Okay, then these are like terms. So we've sine x cos alpha, and here we've 3 sine x cos alpha. So if I subtract that over here, I get 5 sine x cos alpha. That's my 8 sine x cos alpha minus 3 sine x cos alpha. And then if I add this over here, I get 11 sine alpha cos x. Okay, now we're nearly done, but all I need to do is, I just want to keep this here. If I divide the left by cos x, so I have 5 sine x over cos x, and I divide the right by cos alpha, sine alpha over cos alpha. Sine over cos is tan, so I've got it. This is 5 tan x equals 11 tan alpha, which is what we wanted. Q, E, D. Okay, that's part B. Part C. Hence, solve to 1 decimal place this. Okay, now, guys, I am going to copy this down so I can see what's actually happening. Okay, this is going down here. Okay, so he says, hence, solve to 1 decimal place this. Okay, so in this situation, x is 2y and alpha is 30. So let's just kind of show you what I mean by that. 2y is x and this is alpha, because it's 8 sine x minus alpha equals 3 sine x plus alpha. So then I can kind of just change this. This is why it's a hence question, guys. I can change it into this. I can say, okay, I can say 5 tan 2y equals 11 tan 30. Okay, then I can say tan 2y is equal to 11 tan 30 over 5. So tan 2y equals 11 tan 30 over 5. I can do with my calculator. That is 11 times tan 30 divided by 5, which is this as a decimal. It is this 1.27017. 1.27017. Okay, and we're going between 0 and 180. So we only want, although actually, sorry, be careful because it's 2y. If y is going between 0 and 180, then 2y is going between 0 and 360. Okay, so 2y is equal to, so if we do the inverse tan of 1 point, well, that thing, okay, inverse tan, let's just do ans. That'll do the answer. This is 51.786. So this is 51.786, and then I'm going to do comma. So again, if I look at my cast diagram, guys, like this. Okay, cast diagram, C-A-S-T. Where can 2y be? Well, it's positive, so 2y has to be in the A or in the tan quadrant. Now, y is between 0 and 180, but 2y is between 0 and 360, so I can use this quadrant here. So 2y is 51.786, or that would be this guy here. Let's draw it maybe there. That's your 51.786. Or here, which is 180 plus 51.786. So let's just do that. 180 plus 51.786. And that is 231.786 to 231.786. Okay, so these are my 2y's, but I'm trying to find y, so I have to divide them both by 2. So let's do that. Let's do this one first. Divided by 2 is 115.9. This will be 115.9, and then the other one is 51.786 divided by 2 is 25.9. So this is 25.9. Okay, that's question 7. Question 8. Solve 5p squared minus 9p plus 4 equals 0. Okay, so guys, this is a quadratic. Again, hopefully we can do it. So it is, I'm just going to do the a times c method, guys. A times c is 20. That means I have factors of 20 that multiply to give you 20 and add to give you negative 9. That would be negative 4 and negative 5. Okay, so I make this 5p squared minus 4. Let's put the 5, guys, why not? Minus 5p minus 4p plus 4 equals 0. So I just change the negative 9p to minus 5 minus 4. This then becomes, factorize the left 2, 5p into p minus 1 minus 4 into p minus 1, minus to give you this plus, equals 0. 5p minus 4, that's 5p minus 4, and then the p minus 1 equals 0. Okay, guys, if you don't know that method, you need some method to know how to factorize this. Then you can say 5p minus 4 equals 0, p equals 4 over 5, and here p minus 1 equals 0, p equals 1. So those are the two solutions. Okay, then part B. Hence solve this. Give your answer correct to 3 significant figures where appropriate. Okay, so what we have, everyone, is this is what I call a quadratic in disguise. So this is actually 5. So 5 to the 2x plus 1, guys, is 5 to the 2x times 5 to the 1, because you would add the powers, which is actually 5 times 5 to the 2x. So this is 5 times 5 to the 2x minus 9 times 5 to the x plus 4 equals 0. If we let's just write it here, let 5 to the x equal y. We then have 5 times, this is 5 to the x squared, because, guys, 5 to the x squared is 5 to the power of x times 2, which is 5 to the 2x. So this becomes 5 times y squared minus 9 times y plus 4 equals 0. Now, hence, he said, guys, hence solve this. So obviously I'm going to use part A. So part A has given us these two solutions. So therefore, let's write it here, y equals 4/5 or y equals 4/5, or y equals 1. Now we have, everybody, we have y is equal to 5 to the power of x. So I'm just going to move down here, and I'm going to say, therefore, 5 to the x equals 4/5, or 5 to the x equals 1. Okay, now what are we trying to find? We're trying to solve this. So x, guys, if I have 5 to the x is 4/5, x is equal to log 4/5, or 0.8, let's just call it 4/5, to the base, or with base 5, log 4/5 base 5, and here I just have x equals 0. Let me just make sure though that that actually works, guys. X equals 0, yeah, that is correct. If 5 to the power of 0 is equal to 1, so here x is equal to 0. And then this one, log here, log base 5, 4/5, or 0.8, and I get negative 0.1386. So x equals, what did I say, negative 0.1386, or x equals 0. Okay, that is, guys, I think part B. Okay, he says 3 significant figures, guys, so let's just change that to negative 0.139. Okay, then he says the curve with this, okay, I'm just going to bring this down here, guys, if you don't mind. Okay, he says the curve with this equation intersects with this at 2 points. Find the coordinates of these 2 points. Okay, so firstly, to find where two curves intersect, guys, generally, if you have them y equals and y equals, you just equate the two y's because they will meet when they are equal. So we're going to go 5 to the 2x plus 1 plus 5 to the x equals 2 to the 5x plus 1 minus 4. Okay, this, guys, is 5 times 5 to the 2x. Or actually, I can leave that for a second, guys. I'll just show you how I think this equation will become the original equation. So 5 to the 2x plus 1 plus 5 to the x equals 2 times. Now this is 5 to the x times 5. This, guys, you want to get very used to, right? 5 to the x times 5 minus 4. Then, well, let's do another step. 5 to the 2x plus 1 plus 5 to the x equals 2 of these is actually 10 times 5 to the x, because it's 2 times 5 to the x times 5, which is 10 times 5 to the x minus 4. Subtract to the left, I get 5 to the 2x plus 1 plus 5 to the x minus 10 to the x is minus 9, sorry, 5 to the x, 9 times 5 to the x, and then plus 4 equals 0. Now that is, everybody, this equation, sorry, this one, 5 to the 2x plus 1 minus 9 times 5 to the x plus 4 equals 0. So we know the solution is x is negative 0.139. So x equals negative 0.139, and x equals 0. That is the solution of this. So the intersection points are going to be, well, these x's and whatever the y is. And the y I can get just from this. So let's just do y equals 5 to the 2 of these minus 0.139 plus 1 plus 5 to the power of 1 of these, 139, and this one will just be y equals 5 to the 0 plus 1, which is 1, plus 5 to the 0. This one's easy, guys. It's just 5 plus 1. 5 to the 0 is 1. 5 plus 1 is 6. And this one, I will need a calculator. Okay, 5 to the power of 2 times negative 0.139 plus 1 plus 5 to the power of negative 0.139 is 3.9949. 3.9949 to 3 significant figures. That is actually 4.0 4.00. So let's just say that that is approximately equal to 4.00. Therefore, the points of intersection, the coordinates of the 2 points where they intersect are negative 0.139, 4 and 0.6. Okay, that's question 8, guys. Next is question 9. A, solve the equation this. Okay, so 6 marks, guys. This is not going to be simple. Note the bases are different. I think let's put everything into the same base, and since one of them is a letter, let's go with, let's turn this into base 3. Okay, so to change the base, we go 2, and then I do log, you have to know this, guys, although it's in the formula sheet at the front. So log 9 over log p, and then choose any base you want. So choose base 3, for example, base 3. Then plus 3 log p base 3. This is already base 3, and then we'll just leave that as 8. Okay, then log 9 base 3, that is equal to 2. Now, obviously you have your calculator, guys, but that's definitely something I want you to know. 3 squared equals 2, so log 9 base 3 is 2. Okay, so that's 2 times 2 over this, so it's actually 4 over log p base 3 plus 3 log p base 3 equals 8. Okay, I have this in the denominator. I always say, guys, if you have something in the denominator and you don't like it there, multiply across, but multiply everything by log p base 3. So that will remove it from here. That'll give me 4 plus, and then it will be this squared, because it's log p base 3, times log p base 3, which is 3 log p base 3 squared. And then this has to equal 8 also multiplied by log p base 3. Now this is, again, guys, what I like to call quadratic in disguise, or a hidden quadratic. So this is then, let's just rearrange it to 3. Well, let's do the let first, guys, just because it'll be a bit nicer. I'm going to say let y equal log p base 3. Okay, so this then becomes 3y squared, this, minus 8y, I'm going to subtract the 8 log p, and then plus 4 equals 0. We then factorize this. Factors of this, I'm going to do it my quick way, guys, but feel free to do it your a times c method. I do it like this: 3y and y, 2 and 2, minus and minus. I do it because it's like 3y times negative 2 is minus 6, and y times negative 2 is minus 2y minus 6y minus 2y gives me minus 8y. Okay, then I can say that either 3y minus 2 equals 0, y equals 2 over 3, or y minus 2 equals 0, y equals 2. Y is log p base 3, so I'm going to change that to log p base 3 equals 2/3, or log p base 3 equals 2. So now we have a situation where p here is equal to 3 squared, which is 9, and here p is equal to 3 to the power of 2/3. Now you can leave it like that, or you can do 3 to the power of 2/3 like this. Give it as a decimal. I don't think he said in any particular way. So 2.08. 2.08. So your two answers are this and 9. Okay, that's, well, sorry, that's question 9A. Now I need to do B and C. I will, guys, I have to do this. Okay, so we have solved the part A. Okay, let's do part B. So he says, given that log 3 base 2 equals this, find the value of k. Okay, so again, guys, I'm going to change the base. I'm going to say, so I can't do much when the base is different, so let's change the base. Generally, you want to go down, make the bases smaller. So if I have base 4, let's make that base 2. The same as this one, rather than trying to bring this one up to base 4. I mean, it will still work, but it's just easier doing it this way. So this becomes log, same idea, guys, it's 3 to the k over log 4 and then base 2 like this. The bottom is 2, so this becomes log 3 base 2 equals log 3 to the k base 2 all over 2. Log 4 base 2 is 2. Now I can multiply across by this 2 here. This gives me 2 log 3 base 2 equals log 3 to the k base 2. And then I can put that 2 up here. I'll just do this, guys, to skip a step, which gives me log 9 base 2 equals log 3 to the k base 2. So that means that if the logs are the same, the basis is the same, then this guy, this 9, has to equal 3 to the k. So I'm just going to go up here. Therefore, 9 equals 3 to the k. 3 to the power of what equals 9? Well, it's obviously 2. K equals 2. Okay, that's part B. Part C. Okay, this looks quite scary. Show that this equals this. Okay, sometimes, guys, when things look scary, it means they're actually not too bad. Anyway, let's find out. This minus this plus this equals this. Okay, again, guys, we want to change the base. Now this time, because he's told me base 4, I'm going to have to change all of these to base 4. Okay, so let's start. This first one is, well, let's just leave the 6x there for now. So 6x log x base 4 minus 3x, and then I'm going to do log 3 over log 2 base 4. Let's change the base rule. Minus 5 log x base 4. This one is fine. And then this one is plus 10. Again, log 3 over log 2 base 4. Okay, this equals, okay, let's just leave this for now, 6x log x base 4 minus 3x log 3 base 4 over, now guys, log 2 base 4 is equal to a half. Now let me just show you why that's the case here. If I said log 2 base 4, imagine I said that equals, I don't know, let me just pick a different letter, like a, right? That means 4 to the power of a equals 2. So 4 to what power gives me 2? Well, it's actually 4 to the power of a half, because it's the square root. Or you could think of that as 2 to the 2a equals 2 to the 1, 2a equals 1, a equals a half, like that. Anyway, that, which is obviously separate, is why log 2 base 4 is equal to a half. So I'm going to put a half here like this, minus 5 log x base 4 plus 10 log 3 base 4, and again over a half. Okay, now we're trying to get to here, guys, but we will get there. Let me just move down. So this becomes 6x log x base 4 minus, now if we divide by a half, this is the same as multiplying by 2. So this becomes 6x log 3 base 4 minus 5 log 5 log x base 4, and then this is plus 20 log 3 base 4, because I'm flipping the half, so multiplying by 2. Okay, now you'll see, guys, I think we are nearly there. Okay, so this becomes, let's have a look. This becomes log x base 4 to the power of 6x. Now, why am I doing that? Well, that's something that looks a bit like what the answer is at the end. So I'm putting this up here because that's a rule of log. You can put, if you have a log b is equal to a log b is equal to log b to the power of a. Okay, that's one of our rules. So I'm going to do that with all of these. So this is minus log 3 base 4 to the power of 6x minus log x base 4 to the power of 5 plus log 3 base 4 to the power of 20. Okay, now I can just essentially add these. So I have, this is log, I can add my two logs here. So this is going to be this plus this. So let's just do the positive ones first, guys. This plus this. Okay, so this will give me log. Again, when I add logs, I multiply what's in the log. So it's log a plus b is equal to log ab. So this is equal to log x to the 6x times 3 to the power of 20. Okay, and then I can subtract these two, which is log 3 to the power of 6x times x to the power of 5. Okay, so that's just subtracting. It's like subtracting this plus this, or like I'm kind of taking out the minus, so I kind of skipped a step there, so just make sure you're okay with that. Okay, this then becomes, I'm going to log a minus log b is log a over b, so it's going to be log of this over this, so it's log of x to the 6x, x to the 6x times 3 to the 20 over 3 to the 6x times x to the 5. Okay, I'm very nearly there. This is log, if I just look at my x's, that's 6x minus 5 because I'm dividing. So that's log, that is log of x to the 6x, sorry, that is log of, let's just do it at the top, log 6x minus 5. And then at the bottom, how does he want the answer actually, guys? 6x minus 5 and then 6x minus 20. Okay, so yeah, so we have 6x minus 20. This is log 6x minus 5, so that's my 6x minus 5. And then at the bottom, it's 3 to the power of 6x. And then if I want to bring this 20 down underneath the line, it becomes 6x minus 20. So, right, that's actually, guys, a pretty hard question. Let me just check that that's right. X to the 6x minus 5, 3 to the 6x minus 20. Okay, so that's it, guys. Hope that made sense, but yeah, that is definitely a difficult question. Okay, question 10. So I just copied the formula from the formula sheet, guys. This is directly from the formula sheet at the start. So this is 1 plus x. Now in our situation, the x kind of becomes 2x squared. Well, it does become 2x squared to the minus a third. Okay, so in our formula, just to be clear, guys, wherever I see x, I'm going to sub in 2x squared, and wherever I see n, I'm going to sub in minus a third. This question is actually, in my opinion, pretty straightforward because there's a formula, you just have to sub it in. Okay, so it's 1 plus n. So n is minus a third. X is 2x squared. Then I have plus minus a third. Then minus a third minus 1 is minus 4 over 3. Use your calculator, guys, if you need to do that. Minus 1 over 3 minus 1. Hopefully you don't. Over 2 factorial. And then times 2x squared. 2x squared. Sorry, it's 2x squared. Squared. Like that. And then finally, plus, let me just do this here so I have space. Plus, this will be my last term because he says up to x to the 6, and when I square a square, I get x to the 6. I'll explain that in a second. So it's n minus 1, which is minus 4 over 3, n minus 1 again, which is minus 7 over 3, and then it's 2x squared cubed. Okay, so this will give me guys, the x to the 6 when I square it, and this is all over 3 factorial. Okay, we're stopping there, and that's why, guys, I'll say this is approximately equal to this. Okay, and then I just have to simplify this. So it's 1 minus, sorry, that's a 1 minus, because of this minus, and then it's 2 over 3 x squared. So 1 minus 2 over 3 x squared. This guy, now I say, guys, this is an easy question. Well, it's a straightforward question, but it's also very easy to make mistakes, so be super careful. Minus minus is plus, so this is going to be plus. Then I have 4, 1 times 4 is 4, and this is 4. So it's 4 times 4, because 2 squared is 4. I'm going to maybe skip a step here, guys, but 4 times 4 is 16. So it's 16 over, and then at the bottom, I have 3 times 3 is 9, and then 9 times 2 is 18. So it's 16 over 18. Now just make sure you're clear on how I've got all that. And that's x to the power of 4. And then this is going to be minus minus minus, so this will be minus. And okay, here I have at the top I have 4 times 7 times 8. So that's 28 times 8. 4 times 7 times 8, because 2 cubed is 8. All over 3 times 3 times 3 times 6. So that's 27 times 6 at the bottom. So 3 times 3 times 3. 3 factorial is 6, because 3 times 2 times 1 is 6. And then that is all x to the power of 6. Okay, this equals, let's simplify, 1 minus 2/3 x squared plus, divide above and below by 2, 8 over 9 x to the 4, and then minus, let's just do 2 into that goes 3 times, 2 into that goes 4 times. So now I have 4 times 28. 4 times 28 is 112. So that's going to be 112 over 81. 27 times 3 is 81. X to the 6. Okay, that's part A. Part B, state the range of values of x for which the expansion is valid. Okay, the expansion is valid. This is part B. The expansion is valid for this, guys, is where x is less than 1, or the modulus of x is less than 1, but our x is 2x squared. So it's where the modulus of 2x squared is less than 1. And that is the same as where, okay, I'll just move down here. The modulus of x squared is less than 1 over 2. I'm going to divide both sides by 2. And the modulus of x squared is less than a half, where the modulus of x is less than root 1 over 2, which is 1 over root 2. So the size of x, if you like, has to be less than 1 over root 2, which means, let's do it over here, x is bigger than negative 1 over root 2 and less than 1 over root 2. Okay, that's part B. Part C, D and E. Okay, guys, I'm going to have to do this again. This thing here. Okay, now he says f of x is this. Obtain a series expansion for f of x in ascending powers of x up to including the term n x to the power of 6. Okay, so we now need this. We need this expansion. So it's this. Let me just copy and paste. Okay, so this is the bottom bit of f of x. So f of x is actually equal to f of x equals this times, so it's this in a big bracket, times 2 plus kx squared. Now why is that? Because look, this is 1 plus 2x squared to the third is the same as 1 plus 2x squared to the negative a third. So when we times this by this, if you like, it's that times 2 plus kx squared, which is the same as this. Okay, now he wants it a series expansion up to x to the power of 6. So I'm going to say approximately equal to, and I'm going to do the 2. First I'll do 2 times all of this, and then I'll do kx squared times all of this. So the 2 times all of this will be firstly the 2 minus 4 over 3x squared, 2 times this, plus 16 over 9x to the 4, 2 times this, minus 112 times 2 is 224, 224 over 81 x to the 6. Okay, and then plus I'm going to do kx squared times 1, so that's kx squared, and this times this is minus 2 over 3 k x to the 4, and then I'm just going to do the last term, which is plus 8 over 9 k x to the 6. Now this is why I wrote approximately equal to, and this is why I'm stopping here, because if I do this term times the final term, I'll get x to the 8, which is beyond what he wants. He only wants it up to x to the 6. So he wants each coefficient in terms of k where appropriate. Okay, so that means we do have to add the few things together. So our constant is just, we only have one constant term, is 2. Great. Our x squared term, let me just highlight these. We've this guy, which is minus, be careful, and we've this guy. Okay, so that's going to be, I'll do plus, and then I'll do k minus 4 over 3 x squared. So I've just kind of joined the k and the minus 4 over 3 together. Then I'll do the x to the 4 terms. That will give me same kind of thing here, guys. I'm going to do 16 over 9 minus the 2/3 k, this guy, x to the 4. Okay, so just to clarify, that's him with him. And then finally, this guy with this guy, I will do, I'll start with the 8 over 9, guys. It looks a bit better. 8 over 9k minus 224 over 81, close brackets, x to the 6. Okay, tricky, guys. Easy to mess up. Just be super careful. Okay, that's part C. Part D. Given that the coefficient of x to the 4 in the series expansion of f is 0, find the value of k. Okay, so that's easy. That's just this equals 0. The coefficient of x to the 4, so it's 16 over 9 minus 2/3 k equals 0. Solve this. I'll just do it here. I'll say 2/3 k equals 16 over 9. Cross multiply, divide both sides by 2, whatever you want to do here, guys. 8. I'm going to say 9k equals 3 times 8 is 24. Cross multiply. K is 24 over 9, which is equal to, divide above and below by 3, 8 over 3. Okay, finally, he says, 5 marks, hence use algebraic integration to obtain an estimate to 4 decimal places of this. Okay, so we're going to integrate f of x from 0 to 0.5. The integral from 0 to 0.5 of f of x, so this is f of x, so it's 2 plus, now our k, guys, is 8 over 3, so it's 8 over 3 minus 4 over 3, which is 4 over 3, x squared. This guy's going to be 0, because if you sub in k there, you're going to get 0, because that's how we got k, so that's gone. And then this one is, so we've 8 over 9 times k, so that would be, guys, 64 over 27 minus 224 over 81. Okay, so that, guys, let's just do that with the calculator. Can't be dealing with that. That is 64 over 27 minus, what did I say, 224 over 81, which is minus 32 over 81. So that's minus, so it's minus 32 over 81, minus 32 over 81, x to the 6. So it's the integral of this dx. Now he wants, guys, let me just make sure, he wants to use algebraic integration, so we can't just do it on the calculator, to obtain an estimate to 4 decimal places. Okay, so here we are going to integrate. So this becomes the integral of this. So 2x, so 2 becomes 2x. This becomes 4x cubed over 3 times 3, which is 9, because we divide by the new power, and there's already a 3 there, minus 32x to the 7 over 7 times 81. Let's do 7 times 81 here. 5, 6, 7. 5, 6, 7, x to the 7. Okay, nice. Close this, and it's from 0.5 to 0. So this will become 2 times 0.5 plus 4/9 times 0.5 cubed minus 32 over 5, 6, 7 times 0.5 to the power 7, and then minus, so we sub in the top power, and then we subtract and we sub in the bottom power, and when you sub in that bottom power, it's just going to be 0, because 0, 0, 0, and then this, whatever this is, with the calculator. Okay, let's do it. 0.5 plus 4 over 9 times 0.5 cubed minus 32 over 5, 6, 7 times 0.5 to the power of 7. Really hope this is right. It's this, but he wants it as a decimal, I believe. So it is 1.05511. So this is 1.05511. How many significant figures? 4 decimal places. So this is approximately 1.0551. Okay, that's question 10. Question 11. The curve C has equation this. The point P lies on C and has x coordinate 4. The line K is the tangent to C at P. Okay, fine. Find an equation for K, giving your answer in this form. Okay, so guys, K is the tangent to C at 4. Okay, so if we want to find the equation of a tangent, remember a tangent is a line. So it's basically, guys, this is, it's a quadratic, and we want to get the equation of this line that is tangent to the quadratic somewhere here. Okay, so how do we do it? Well, we need a point and we need a gradient. To get the equation of any line, we need a point and we need a gradient. And then we can, well, we can then use the formula. Y minus y1 equals m into x minus x1, or y equals mx plus c, whichever formula you prefer. I prefer this one, guys. Y minus y1 equals m into x minus x1. Okay, so let's get the point. To get the point, let me just change the color here. Okay, the point. When x is 4, so x equals 4, y is equal to x squared plus 2 over 3, if I just divide by 3 to get y. So y equals 4 squared, which is 16, plus 2 over 3, which is equal to 18 over 3, which is 6. So the point is therefore 4, 6. Okay, then to get the gradient, the gradient, guys, is all about the derivative. So if y is equal to, I'm just going to change this into a third x squared, if you're okay with that, guys, plus 2 over 3. I'm just splitting this up so they're both divided by 3. And then I get dy dx. Dy dx equals multiply by the power, 2 over 3x, subtract 1 from the power, and then this actually just becomes 0. So the derivative is 2/3 x. And then I'm going to say at x equals 4, dy dx equals 8 over 3. So I have the gradient. The gradient is now 8 over 3. I'm going to write, therefore, m equals 8 over 3. So then I just use the formula, y minus y1 equals m into x minus x1. Y minus y1 is 6. M is 8 over 3. X is x. And x1 is 4. So I have this. This is the equation of the line. This is the equation of the tangent, k. But he wants it in this form. So fine. I'm going to, first step, multiply by 3, guys. So I have 3y minus 18 equals 8. Well, I'll just multiply this out in one go, guys, if you're okay with that. 8x minus 32. The 3 is gone because I multiplied across, and then I multiplied out the bracket. And then finally, I can get 8x, leave this on the right, minus 3y, and then minus 32 plus 18 to this side is minus 14. Actually, sorry, I just realized he wanted it in this form, which is ay. So sorry, 3y equals 8x minus 32 plus 18 is minus 14. So this here is our answer. Okay, that is part A. Part B. The line L is the normal to C at P. Find an equation for L giving you answer in this form. Okay, so 2 marks, guys. That's because most of the hard work is done. We just need to find the gradient of the normal. So the gradient of the tangent, guys, I can sometimes call this MT, is 8 over 3. So the gradient of the normal is the negative reciprocal, so it's negative 3 over 8. Then we can use this formula again. Y minus y1 equals m into x minus x1. We have y1. It's the same point, guys, because the normal and the tangent both cross at the same point, but their gradient is different. This guy's gradient is negative 3 over 8. Then we have x minus x1, which is 4. Multiply across by 8. 8y minus 48 equals, I'll do this in one go, guys, negative 3x plus 12. And then he wants in this form again, so I'll go 8y equals negative 3x and then 12 plus the 48, which is 60. Okay, that, guys, is part B. Part C. Find the area of the triangle bounded by the line K, the line L, and the x-axis. Okay, so, guys, I just brought the question down here so we can read it. This is K, and this is the line L. Okay, now this line is, okay, well, let me just show you something actually first. So this curve, guys, this is y equals a third x squared plus 2 over 3. This is a quadratic. It looks something like, I don't know, something like this. It actually will go exactly, its minimum will be on this point here. Okay, now when x is 4, we have this this point where this is the tangent. So this is the tangent it's meeting here. Now, if it makes you feel better, guys, we could rearrange this to 8 over 3x minus 14 over 3. And this is minus 3 over 8x plus 60 over 8. So this is going to look something like, it's going to have a minimum there. So guys, let me just try and draw this in a way that makes some bit of sense. So it's going to have, it's going to have a y-axis where it crosses the y-axis at negative 14 over 3, so down here somewhere. But what's important is this point here is where the normal is going to be. So, okay, guys, I'm going to have to bring all of this a bit to the left, and I think I'll actually bring all this down here, because now I have my normal. So this is my k, and my normal will go through this at a right angle like this. Okay, nice. So this is L, and this is like 60 over 8, whatever. It doesn't really matter, because what we're trying to do is we're trying to get this area here. Now, to get that area, we need base times height. But the key part to this whole question is that they both meet here at that point. Now, that point is, remember we got it from the start, 4. The x coordinate is 4, and the y coordinate is 6. We got it from subbing in 4 here. You get 4 squared is 16, plus 2 is 18, divided by 3 is 6. So this point is 6. So my height is actually 6. Now, what is the base? Well, the base, I need to get these two x-intercepts and subtract. So for L, let's do L. Okay, for the L graph, I'll actually go back to this top one here. I can just say minus 3x plus 60 equals 0. 3x equals 60. X equals 20. Okay, so that's actually this guy. So this guy is 20. And then for k, I can, again, let's go back to this top one. I can say 8x minus 14 equals 0. It's because y is 0, guys. So it's 8. What is that green? 8x minus 14 equals 0. 8x equals 14. And then x equals 14 divided by 8, which is 7 over 4. Okay, so that distance here, from here to here, is actually going to be 20 minus, sorry, that's 20, and that there is 7 over 4. So if I do 20 minus 7 over 4, let's do that. Oh, let's just do it here. 20 minus 7 over 4 is, that's actually 80 over 4 minus 7 over 4 is 73 over 4. So that base here is 73 over 4. So now the area of the triangle area is just equal to a half base times height, a half 73 over 4 times height, which is 6, and then, I don't know, do that however you want, guys. Let's just use the calculator. This is a half, 0.5, times 73 over 4 times 6, which is that, as a decimal, 54.75. So this is 54.75. Okay, finally, the finite region bounded by C, the line L, the x-axis, the y-axis rotated through 360 degrees. Use algebraic integration to find, to the nearest whole number, the volume of the solid generated. Okay, this is volume of a revolution, guys. It is the area of the triangle. No, sorry, it's this one. It's the area of the region bounded by the line L, x-axis, y-axis, and curve C. So it's, let me remove this, guys. I'm going to get rid of that. because it's this region. I'm going to get rid of this too. And actually that. Okay, I'll leave this line here. I don't need that. But I'll show you why I want to leave that line there in a second. So it's actually this region here. It's all of this. It's that region. I'm going to rotate it around the x-axis, volume of revolution. But what I'm going to do is I'm going to split it into this, and let's go with this. And this one will be the integral of the curve C from 0. This is 0, this is 4, and this is 20. So it'll be C from 0 to 4, and L, which is this line, from 4 to 20. Now, what I can do, guys, is this will become a cone. When you rotate this line around the x-axis, it becomes a cone with height. The height of the cone, that height there, is just going to be 16. 20 minus 4 is 16. And this height is 6, so maybe I should have left that 6 there. So when I rotate that around, look, you rotate it here, you get a cone like that, well, with a straight line like this. So that's why that's a cone. You could integrate it, but it ends up being way more difficult if you try to integrate the line rather than just using the cone. But it will work. You'll get the same answer. But you have to certainly do the volume of revolution formula for the curve. Okay, so the volume is equal to pi times the integral from 0 to 4, that's from here to here, of y squared. Now my y is this guy. It's a third x squared plus 2/3. So this is a third x squared plus 2/3, and it's that squared. So it's pi times y squared dx plus the cone. So it's that plus the cone. So let's do this first. This is pi times, let's expand the bracket. This is this squared, which is a 9th x to the power of 4, that's squared, plus 2 times this, which is 4 over 9 times x squared. That's just 2 of these times this, plus 4 over 9 dx, plus the cone. Let's just do that here. This is a third pi r squared h. So it's pi, r is 6, that is your radius. So it's 6 squared, and your h is 16 from that. Okay, this then becomes pi times, I need to integrate this. So it's, well, let's do it like this. It's x to the 5 over 5 times 9, which is 45, plus 4x cubed over 27, because I do raise the power to 3, divide by 3, gives me 27, and this is just 4/9 x, and this goes from 0 to 4. This is plus 36, well, that's 36 divided by 3 is 12. 12 times 16, 12 times 16 is 192. So this is 192 pi, and this guy becomes pi times, the first one will be 4 to the 5 over 45, plus 4 times 4 cubed over 27, plus 4 times 4 over 9, and then it's minus 0 if you like, because that's 0. When I sub in 0 here, it all turns to 0, plus 192 pi. Okay, nearly done. I have to, let me just move over here. I have to do this. So pi first, so it's pi, where are you? Pi times this 4 to the power of 5 over 45, plus 4 over 27, 4 times 4 cubed, that's 4 to the 4, but whatever, plus 4 times 4 is 16 over 9. Okay, that equals 106.86. That is 106.86. So it's 106.86 plus 192 pi. This is all to the nearest integer. So let's do 192 pi. 192 times pi is, as a decimal please, 603.18. So, well, actually, let's do this, guys. Plus, so it's this plus 106.86, which is 710.04, which is 710, which is right, thankfully. Okay, that is 710. I don't know what we're in, guys. We're in centimeters, or it doesn't even say. The volume is 710. Okay, that's it, guys. I think that's the last question of the paper. Yeah, I'll see you for paper 2.